This is a pre-built version of the application. So let's go ahead and run it and do all the operations that we need here, and then go over what just happened. Now this is the equation of an elliptic curve over prime fields. So we perform all operations in mode P, where P is prime. And we want the values of x and y that would result in this equation being satisfied. So for x is equal to 0, we end up with this result, and we have the same result here and here. So we end up with those 2 points satisfying the equation. And for x is equal to 3, we end up with this result, and we have the same result here and here. So we also end up with those 2 points satisfying the equation. So we end up with 19 points that satisfy this equation, including the point at infinity, O. And we have a theorem that says that if we have a finite cyclic group with prime order, then all elements, meaning all points in this case in that group, are generators of that group, meaning all those points are primitive elements. So if we pick any point here, it will end up generating the entire group, and we picked this point 5 1, and it ended up generating the entire group 3 times. So each column here is the entire group being generated. So here we did 57 hops, and we can see the cyclic behavior. So 5 1 is repeated here and here, and 6 3 is repeated here and here, etc. Now if we have a huge number of points in the cyclic group, then we would not be able to do this, since it will take forever with slow hopping. So here we did fast hopping using the double and add algorithm, and we'll quickly go over how this works while writing and test running the application. So here we are doing 13 hops, and we ended up at this point, and this is generator point G, and D is the number of hops. And we'll also go over what this means while writing and test running the application. Now